Hey kids, today is Thursday, and if you are at school, you will notice that I am not here today. Mrs. Wilson is here for you. I think I mentioned that on Tuesday when I last saw you. But what we're going to do today is go through some information again on rock cycle. This will be our last one of these, wrapping this up. But there's three new terms: uplift, subsidence, and rift zone, and you'll need to know how those impact the rock cycle. Okay. So, what is the rock cycle? We have been on this for about a week now. As it says, rocks may seem very permanent, solid, and unchanging, but they do change. Okay. And we have talked forever, you guys are probably tired of it, but about weathering, erosion, and deposition. And that's three of the main things that change the rock cycle. But the exact definition of rock cycle is a series of processes in which rock changes from one type to another. So, a series of processes. All right. Some of the factors that affect rocks are temperature and pressure. We looked at that with minerals and now with the rock cycle. That's metamorphosis or metamorphism. Okay. And then, of course, weathering, erosion. We'll add deposition. Weathering breaks it, erosion takes it. Okay. And I know you guys can read, but I'm going to read along with you. Just know that all the rocks can change into one another at some point of time. And the rock cycle is an incredibly slow process that can take billions with a B of years. All right. So this is a very detailed, very down to the smallest parts rock cycle. But just like we've talked about, okay, let's say we'll start with igneous rock, okay? It can be weathered, and then it is eroded or transported, moved, and then dropped off, okay? In this case, into water, okay? Lake, ocean, river. And then that is buried and compacted or cemented, which we've talked a lot about. And then it turns into sedimentary. That point possibly could be a heat and pressure, which turns it into metamorphic. It would melt, crystallize, and we go back around again. So that's just one example of the rock cycle. All right, here's another detailed drawing. I want you to look at this question. It wants us to label the missing rock types and the processes on the diagram. So these might look separate, but these are just big hunks of earth that they've separated out. So if you look here, okay, this will tell you right here, all of the arrows that make Nolan Isler happy. Miami Dolphins, teal blue, okay? All right, that's what those stand for. So you have this that is weathering, this that is weathering, and weathering over there. So if we click on A, we will see again that it is weathering, erosion, and deposition. All right, so then they want us to know what type of rock this would be here that would form from weathering, erosion, and deposition. Think to yourself, and I think you'll remember this is, after weathering, we have what is called sediment. So this would be a sedimentary rock. Okay, the sedimentary rock you can see has temperature and pressure. Temperature and pressure then would be letter C. The gold lines represent temperature and pressure. All right, and then you can see what else can happen. It can melt into magma. The sediment can melt into magma. The igneous can melt back into magma. Then it cools into igneous. All right, this bottom question is, list one process that happens above Earth's surface. Okay, so there's really only one main thing that happens above the surface, and that would be weathering, erosion, and deposition. One thing that happens below, well, we have a couple options. They went with melting. So again, that's a really good rock cycle. If you need to maybe screenshot that, screen grab as they say, or look back at that for support. Okay, we mentioned this just so briefly, and maybe not even in all the classes, but during the gizmos if you were in class. The tectonic plates, okay? How does their movement, the plates of the earth, affect the rock cycle? Okay, the motion can either move rock upward, or it can drive it down, depending on how the plates are moving. So there are two types of vertical. Vertical means up and down. Two types of vertical movements. One's called uplift and one's called subsidence. Subsidence, subsidence is what I say. All right. So the first word you need to know, and here is a good example right here in this picture, is called uplift. And uplift is the rising of regions of the crust to higher elevations, which increases the rate of erosion. So obviously, as the crust goes higher in this example, okay, maybe if I use my pen here, okay, as this goes up, okay, it's obviously going to be more susceptible to wind, okay, and all different types, agents is the word they keep talking about, of weather. Okay, so that is uplift. Then there's subsidence, and that is sinking. If you think of a submarine, like that would travel under the surface of the ocean, sub means below. So subsidence is the sinking of regions of the crust. So the crust sinks down, which leads to the formation of basins where sediment can be deposited. So as the bottom sinks down, okay, more sediment can be deposited. Oops. All right. So the question in this, and this is a good one, how does uplift differ from subsidence? Well, uplift is the rising. Think up, it's going up. Subsidence is the sinking. So sub going down. All right, there's one other term I need you to know in this lesson, and that is rift zone. And that's an area where a set of deep cracks form along the plate boundaries. And we're going to see some examples, but there is one. Let me find my handy dandy pen. There is one right here, if you can see it. Okay. All right, and here's a drawing. As the plates pull apart, so here's plates. As they pull apart, the crust in the center of that rift zone subsides or goes down. And on the buried rocks, blocks of the crust are buried rocks is reduced, allowing them to rise to the surface. So rocks are allowed to rise up through these rift zones. Okay, so here is a picture of three different things, and we're going to label them and then explain a pathway that the rock cycle might take, what pathway in the rock cycle. So if we look here, that is uplift because we have the arrow, it's going up. Okay, the crust is going up. This is obviously subsidence, it's going down. Okay, and there are rift zones. So let's talk about a pathway in the rock cycle. What pathway in the rock cycle might a rock take if it is subjected to uplift? Well, we talked a couple slides ago, if the crust is higher up, it is more apt to be weathered, okay? So it will reach your surface, be broken down into sediment through weathering. Weathering breaks it, and then form sedimentary rock. All right, there would be an example, okay? That is a fissure. I might have mentioned in class, if you've been an Option 1 student, you'll do a lot of this in the 8th grade, but it's pretty amazing if you look at that. All right, here is a map of Africa, and you can see these plates on this map pulling away from each other, which is leaving this zone right here. And there would be an example of that. And look how deep. Okay. All right. So we're going to just wrap up with a couple questions here. When sediment is pressed together and cemented, it becomes cemented and pressed, compressed. That is always sedimentary rock. All right. When lava cools and solidifies, you get igneous. And metamorphic rock can be altered by temperature and pressure to form a type of temperature and pressure metamorphic. It can become a different type of metamorphic. All right. Last question. Why are rift zones, which we just went over, common places for igneous rock to form? Well, the pulling apart of the crust decreases the pressure that was on those rocks, so the magma forms and solidifies. All right. You've got 5 questions with this. Make sure you take your time and get those done well. And then Mrs. Wilson will be working with you on IXL. She will advise you as to what sections we don't have done for you. Okay? All right. Have a good one.